determine two ways to restrict the domain of that red graph so that its inverse is a function. So currently we look at the red graph and we notice it doesn't pass the horizontal line test. Anywhere I draw the horizontal line, it hits the red graph more than once. So what I want to do is come up with two different ways to restrict the domain. Now, first of all, let's talk about what does restricting the domain mean. And I'll show you with the first way that we could do this. Number one, we could restrict the domain of, so we have this equation, and after it, I'm going to say I'm only going to look at that when the x values are bigger than or equal to 1. So what this means is we still know this is a parabola, but the restriction right here says that our x values can only be bigger than 1, means we only draw part of the parabola. We only draw the part where the x values are bigger than or equal to 1. So what does that look like? Well, I would have this point, and I would have all of this section, but not the other section of the red graph. Can you see that that's still the parabola, but only part of it? So when we restrict the domain, we only take part of something. Now this often happens in real-life examples, because there's, for example, if you throw a ball up in the air, and let it reach its top and come back down to the bottom, and graph height versus time, it'll always make a perfect parabola. However, if you made an equation for that parabola would go down forever. The problem is when you throw a ball up in the air, it eventually hits the ground. I've never seen someone throw up a ball in the air, hit the ground, and keep going down forever. That would be crazy. And so in a real-life example, we sometimes have to restrict the domain by what's possible and what makes sense. So here, if I restrict the domain just to be x bigger than or equal to 1, that'll only be the blue part of the entire red graph. And if I look at the blue part, does it now pass the horizontal line test? Yes. So that means that my inverse is going to be a function. Now when I find the inverse of this equation, that would mean switch x and y, right? This is how we find the inverse of an equation, and we would have to solve for y, so I'll bring the 3 over to the other side. To get rid of the square root, I square root both sides, I remember the plus or minus. And I get y equals plus or minus the square root of x minus 3, add 1 to the other side, plus 1. If I switch my x and y's of just the blue part of the graph, I will only get one of these square roots. The question is, which square root will it be? Will it be the positive one, or will it be the negative one? Two ways to help you find that out. One, we could take points on the blue graph here, which include 1, 3, so on the inverse I'll have 3, 1. I have 2, 4, so on my inverse I have 4, 2. I have 3, 7, so I would have 7, 3. So we could draw a picture. Does that picture look like a negative square root graph or a positive square root graph? So the inverse equation using the graph would be the positive one. another way to tell which one it's going to be. If my domain is restricted to be x bigger than or equal to 1 on my original function, if I switch x and y, that means that on my inverse, my range is bigger than or equal to 1. And then you'd have to think about, does a positive square root graph go up forever? Yes, it does. Does a negative square root graph go up forever? No, it goes down forever. So the fact that the range is bigger than or equal to 1 also tells us it has to be that positive equation. I'm going to switch colors to purple because it asks for two ways to restrict the domain. One way was to take the right half. Can you see another way would be to take the left half? So how would I write that restriction? X less than or equal to 1 would be my restriction. If I did that, and flipped all of those or switched all of those x values, I would get the bottom half of that sideways parabola. And the inverse equation this time the y values would have a restriction now to be y less than or equal to 1, and the equation of that one is the negative square root. So if you get a question like this one on a quiz or a test, you can use a highlighter or different colors of pen. Here it's illustrating. I use different colors to illustrate which part went with which graph. When I did the inverse of the blue graph, it matched up with this inverse equation. Can you still see that this is a reflection over the line y equals x? Questions for practice are 10 and 12.